one orange and break it into two. Each division is called half, or just 1/2 in the vulgar form. What if each half is broken further? The entire orange will be seen to have 4 different portions, and each portion will be called 1/4. What if each of these 4 portions is broken further into 2? The original one orange will now have 8 different portions, and in that order. While this is happening, 2 things stand out. 1. The number of portions keeps increasing with each division, but the size of each portion keeps decreasing with each division. What it means is that division causes multiplication of portions. In fractions, we speak about portions. That takes us to lesson objective number 8, and that is division of fractions. Please follow me as I develop this section. In this section, let us learn division of fractions. Don't forget that it is still under arithmetic of fractions. Permit me to use this illustrative diagram to arrive at a conclusion regarding the law of division involving fractions. Please, closely watch this circle. It is broken into 2 equal portions. This portion and this portion are the same in size, probably. And the size of each half is written to be 1/2. I hope you know why it is 1/2. A whole orange, for instance, was broken into 2, and one portion picked is named as 1/2. That is logical enough. Then next, is it possible to divide this 1/2 further? Yes. If we break it into 2, it means that we are dividing 1/2 into 2 again. That is, this portion called 1/2 broken into 2 again. What it means is that a line has to run across each of these 2 halves to produce what we now find on the right-hand side of this illustrative diagram. Notice that here you have 2 portions and here you have 4. How did these 4 portions come to be? I've just made reference to it. Each of these 2 halves was broken into 2 further, producing 4. That means instead of having 2 portions now, the same orange now has 4 portions. The diagram only tells us one thing, that if we divide each of these halves into 2, there will be 4 portions, and there will be a name or a value assigned to one of the 4 portions. 1 out of these 4 portions came to exist as a result of dividing these 2 portions further into 2. When each portion is broken into 2, altogether we have these 4. The name of this portion before division is 1/2, but the name of each portion after division is 1/4. What it means is that the reason why it has become 1/4 is that 1/2 was divided by 2. Therefore, we make a conclusion with this diagram that 1/2 divided by 2 is equal to 1/4. Let me write it. And here it comes. 1/2, that is this, divided by 2, see it here, that is broken into 2, is equal to 1/4. See it here. From this number operation and result, we can Create a formula for dividing fractions or for carrying out division involving fractions. This 2 is a whole number and 1/2 is a fraction. Permit me to rewrite this 2 to take the structure of a fraction, but not a fraction, so that it gets easy for us to make conclusions therefrom. How do I change this 2 to a structure of a fraction without changing the value of that 2? One of the ways is to divide it by 1. Let me rewrite this number operation as 1/2 divided by 2/1. Please watch. And that is it. 1/2, that is this 1/2, divided by 2. Now 2 is written as 2/1. When 1 divides 2, the result is the same. So this was just done so that it can take the structure of a fraction. Just to make the process easy for us, this one was introduced. And now we go on to conclude that the result of this number operation is 1/4. Please, again, closely look at this number operation as well as its result. Can you deduce anything from that? Can you notice or observe anything from the way the number operation was carried out in connection with the way the result was written? As you are thinking, let me write down what I observed, both in this exercise and former exercises similar to it, so that you compare what you are thinking with what I have written. Please find my observation. And now, this is my observation. Something happened here to turn to this. It is as if this 1 was gotten by saying 1 times 1. That is this 1 here, which is this 1, was gotten by saying this times this. The numerator of the first fraction multiplying the denominator of second structural appearance of 2/1 in form of a fraction. So this we take as denominator of this supposed fraction, though it is not a fraction. So 1 times 1 gave us this 1. And then second one is that this 4, which we find here, which is the denominator of the answer, is likely gotten by multiplying 2 by 2. That is 2 times 2 give us this 4. That is 4 is equal to 2 times 2. If you repeat this exercise with other number operations similar to this, you will find the same conclusion. So there is no need repeating this exercise in so many ways. Just be challenged to go into more exercises. Definitely. Whether you are dealing with division of a fraction by a whole number or fraction by fraction, the conclusion is going to be the same thing. Though not written here, many exercises have been carried out and the same conclusion was drawn. What is the conclusion? It is that we can make from this observation. And what is that? Please watch out as I write the conclusion from this observation, which later turns out to be a law of carrying out a division of fractions. Please watch out. And here comes the conclusion, which has become the law. And here comes the conclusion, which has become the law of dividing fraction, either by fraction or by a whole number. It says A over B divided by C over D is equal to AD over BC. Just like we said 1 times 1 to give us this 1 over 2 times 2 to give us this 1. We say A times D to give us AD over B times C to give us this BC. Therefore, A over B divided by C over D is equal to AD over BC. Let us see some examples of number operations involving division of fractions using this law. And here are the examples of number operations involving division of fractions. The first example says 3 over 4 divided by 5 over 6. Based on that law, in fact, before we proceed, let us remind ourselves of that law, which we have to constantly bear in mind as we carry out this division. Please see the law again as a reminder. And that is the reminder. This is the law of carrying out division with fractions. Let's make progress, please. In conforming to this law, this number operation is carried out this way. 3 over 4 divided by 5 over 6. In this case, our A is 3, our B is 4, our C is 5, our D is 6. What then is our AD? Our AD means A times D. That means our AD will be 3 times 6. See it here. Then over BC. BC means B times C. That will be 4 times 5. See it here. So this is how this became this. Let's now simplify further. 3 times 6 is 18. 4 times 5 is 20, leading us to 18 over 20. 18 over 20 is the answer, but can be brought down to lowest term. How is it done? Let us use the HCF method. That is, we find the highest common factor to 18 and 20 and divide both with that factor. That factor remains 2. So when 2 divides 18, we have 9. When 2 divides 20, we have 10. Therefore, this number operation produced the answer as 9 over 10. Let us also use the same law in evaluating the next number operation in division of fractions. That is 1 over 8, that's number 2. Then divide by 5 over 12. Again, in like manner, our A is 1, our B is 8, our C is 5, our D is 12. What about AD? AD is gotten by saying A times D. So here we have 1 times 12. See it here. What about our BC? BC is gotten by saying B times C. In like manner, we have 8 times 5. See it here. Which means that this number operation produced this. Consequently, we have 1 times 12, giving us 12. Then 8 times 5, giving us this 40. So 12 over 40 is the answer, but can further reduce to lowest term. How is it done? As before, we choose the highest common factor, preferably, to divide 12 and 40. That factor is 4. We have other common factors, but 4 is the highest of such common factors. So if we use 4 to divide 12 and 40, we have 3 over 10. That's because when 4 divides 12, we have 3. When 4 divides 40, we have 10. Consequently, this number operation produced 3 over 10 as the answer. The same thing happens in the case of this number 3, that's I. We have 3 over 8 divided by 2 over 7. Referring to this, we have 3 times 7 over 8 times 2. I hope you understand how this number operation done to this. You should, because already in the previous 2 I explained using this law. And I believe at this point we can do it without constant reference to that law. By now, you should have gotten used to it. So let's make progress. Please, 3 times 7 will give us 21. And 8 times 2 will give us 16. And the answer is 21 over 16. This is not a fraction. it is a division. And when converted to mixed numbers, this is what it is. When 16 divides this 21, each person will have one portion, one whole number, not a portion, please. And then the remaining 5, the same 16 will divide them, giving us one whole number, 5 over 16. Now, watch out for an exercise. So you test out if you have been following what I've been saying regarding division of fractions. And here comes the checkpoint. It says, using the law of division of fractions, evaluate the following operations. Number 1 says 4 over 9 divided by 1 over 2. Number 2 is 3 over 7 divided by 4 over 5. Number 3 is 1 over 4 divided by 2 over 5. Number 4 is 1 over 2 divided by 1 over 5.